Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week. And this may have been one of the more complicated PowerPoints I ever tried to make, so that's why it took so long. But if you're done with your computer for the night, of course, this is always available to you at your convenience. So let's go on ahead and get into what we call jet streaking. All right, so in meteorology, we use something called geopotential height. And it has to do with the potential energy of an air parcel, and it accounts for gravity, the fact that gravity actually decreases as you go up in the atmosphere. And so I took 5 different levels from the weather balloon that went up in Greensboro this morning and read off the heights from those reports. And so the geopotential heights that it reported were 861, 1511, 2990, 5520, and 12,010, all in the units of meters. But the actual height for all of those was 0.87 meters higher than the geopotential height, 1.68 meters higher at 850 millibars, 4.02 at 7, 9.64 at 500, and 33.34 meters at 250. So the rate or the difference gets bigger at a quicker rate as you go up, and that's because the pressure is distributed logarithmically. That if you take a look at the like the distance from, let's say, 1,000 to 600 millibars, okay, it's a much shorter distance from 1,000 to 600. And then if you go 600 to 200, which is the same amount of mass, it takes a lot longer to get up to that 200 millibar level. So that's the way the mass is distributed. So when we show you these maps with height lines on them, they're actually what we call geopotential height and not actual height. So earlier in the daily weather video, I talked about that there was going to be a strengthening jet streak up over the northeast, and that when you look at these jet streaks, you can divide it up into 4 quadrants. You've got the axis of the jet there, and then you draw a line perpendicular to that right through the maximum wind speed, and so it splits this up into 4 quadrants. And you tend to get upward motion in the right entrance region of the jet streak. Now, the jet streak is not moving at the same speed the winds are. It may only be moving at about 30 miles an hour. So the winds are actually blowing through this jet streak. A given air parcel will accelerate into the middle of it and then decelerate as it exits the jet streak. So let's take a look now at how all of this actually happens. Okay, so here's our trusty little jet streak, and of course each one of those colored areas represents a different wind speed. So I think at this juncture, the middle one would be 170 knots, then 150, then 130, then 110, and 90, say, okay? So in increments of 20. So we're going to draw a line through the axis of the jet, just like we did on the previous slide. Draw another one perpendicular right through the middle, or the strongest winds. And we have lower geopotential height to the north and higher geopotential height to the south, okay? Now, it turns out that total energy is potential energy versus kinetic energy, potential energy plus kinetic energy, and that sum has to be conserved, okay? So let's take a look now. Let's say we have 3 little arrows here. The top and the bottom one are not going to realize nearly as much acceleration as the one in the middle, okay? So these arrows representing the wind start to move into this jet streak, okay? But if you think about it, if the kinetic energy is increasing, then the potential energy has to decrease in order to keep the sum constant, okay? So it turns out that as it's gaining kinetic energy, it's got to lower its potential energy, and so that middle arrow rotates, okay, to the left. And so what you end up with, and notice the position of the 2 bottom arrows there, the one in the middle and the one in the bottom, you end up getting divergence aloft, which leads to convergence in the low levels. And so the air is coming together, and then it goes up, and then it diverges at the top, okay? And then the opposite happens as the winds are leaving the jet streak. It's decelerating, so it's losing kinetic energy, and so it has to gain potential energy. And so the arrow then rotates 45 degrees in the other direction, and then you have divergence aloft up in here. So with a jet streak, you get upward motion in the right entrance region, okay, the left exit region, and you get sinking motion here in the left entrance region and the right exit region, okay? So this is going to be the driving force in this event late tomorrow and tomorrow night, or at least during the evening hours. And it tends to create a very, very sharp back edge to the clouds. I mentioned this in the daily weather update, that once the jet axis passes you, it goes from cloudy to clear very, very quickly. And I expect that to happen here after midnight tomorrow night. And then by Wednesday morning, we'll be nice and sunny. All right, I hope that made a little bit of sense. That is bonus weather video number 1 for this week. Number 2 will be coming up on Wednesday. And the next daily update, of course, tomorrow, and more frequent updates as conditions warrant. You all take care, folks, and we'll talk to you soon. See you later.